So in stats class, you are going to use percentage, decimals, and fractions, right? So last section 1.2, we said you can change converting back and forth on those three things: percentage, decimals, and fractions. And this section, we are going to do the comparison, comparing those numbers, okay? In section 1.2, we can convert, change back and forth for all those things. Now we are going to compare them, all right? Then you use calculators, relatively straightforward. We are on section 1.3, your page 9. So it's best for you to print it out the blank notes, then follow along with the lecture. So you write it down, then think at the same time. It will help, okay? For comparison, so that's comparing the fractions first. How do we compare them? Okay, so for two fractions, we say they are equal, means what? If two fractions are the same, remember last section? Then we did this, right? That's a 3/4, and this one is what? 6/8. So we say they are the same, right? Those are same fractions, but they're just writing differently. Then when we actually compare, if they are the same, two fractions are the same, means what? They present the same thing, right? They present the same part of the whole, right? If you say you ate 3/4 of pizza or 6/8 of pizza, 6 pieces out of 8 pieces, same thing as 3 pieces out of 4 pieces, right? So let's see. There are two approaches, okay? First one, change the fraction to equivalent fractions with a common denominator, and then compare the numerator. Then approach 2, on your page 9, use a calculator or a computer to convert the fraction to decimals, then compare the decimals. So you can compare fractions directly for your approach, or that's approach 1, right? Or you can change this to fraction, and you use a calculator, you find out they are the same, so you know they represent the same value, right? Okay, so for the approach A, okay, the first approach 1, and you need your fraction skill. If you have trouble with, then you just use approach 2, change to decimal like this, okay? How do you know 3/4 and 6/8 are the same? What do we do? If you multiply by 2, you end up 3 times 2 is 6, 4 times 2 is 8. You have same denominator. That means times 2, I'm going to cut these more pieces, twice as much. Then if you cut more pieces, you end up, each quarter piece end up is what? You multiply by 2, right? So for the first one, we will use the LCD. So what's the LCD? We just use the common denominator. You can just use 60. Both can use 60. right? If 3 6 becomes 60, that means what? You have to times 10, that would be 30 out of 60. Then if you become from 5/10 to 60s, you have to times what? 6. So you end up 30. Okay, so you have to use the common denominator. So if you do that, do they have the same pieces? Part of a whole on top? Yes. So they are the same. So that means original, which the following fraction pairs are equivalent. Equivalent means they are the same. So they are the same for your first one, right? We are using the first approach to use the same common denominator. Second one, if 2/3 and 40, 60, which common factor and common denominator you will use? Because 60 is bigger, 3 can go into 60, so you just use 60 for both, right? So that would be this one with times 20 times 20, so that would be 40. This one original is 40. Are they the same? Yes. So the original one is, right? Let's look at the next one. It's your C. It says 2, 6, and 8, 18. So we want to use the same denominator. Which one you think you will use? 6 can go into 18, right? So you just use 18. 6 becomes 18. You need to multiply by what? 3. So that would be 6. The original one, 18, are they the same? No. Okay? That's how you do it. Use the same denominator and cut the same pieces for your pizza. Then you can compare to see if they are the same. Next one is asking you, is this one less than this one? If you ate 5/6 of pizza and a 24/30 pizza, which person ate more, right? Then you have to change what? To the same denominator. So for this one, both can use 30. So this is 30. You times 5 times 5. Then 5/6 means what? You ate 25th out of 30 pieces. Then another person 24 out of 30 pieces. Is this less than? No. Remember, this is less than. This is what? Greater than. Right? Or you can less than, or you put a line there. So this one would be what? Less than or equal to. This one would be greater than or equal to. Right? Look at the second one. It says it's 25th hundredth greater than 9/12. So what do you think? Which denominator you can use, make them the same, right? We can use what? 100 times 12, 1200. Or you can use, another one you can use is 600. Okay, just use something smaller you can see. 120 will not work, right? Or you use 1200, it will work. So, but if we use 600, that will work. 600. Okay, if you use 600, Means this one you have to times 6 times 6. 25 times 6 would be what? 150. This one you have to times 5. It's 45. It's 150 bigger than, oops, did I copy right? 600. Oh, I have to times 50. Okay, so 9 times 50 is 450. Is 150 bigger than 450? No. Right? We are using what? The same denominator to compare fractions. Okay, to see if they are the same or one is less than or greater than the other one. If you look the next one, 3/8, is that less than 20/40? What do you think? If you use the same denominator, which one you should use? 88 can go into 40, so you will use 40 for both, right? Then for 8 to become 40, you have to times 5, that would be 15. This one is 20. Is that less than? Yes. So originally, you look at the fractions, you cannot really see which one is bigger, which one is smaller, right? But if you change to same denominator, you can just compare the numerator. You can see it right away. Okay, then let's see. Next one, use the calculator to compare. If both fractions, you can just change it to decimals and to compare them as well, right? That's your second approach. And if we want you to compare, one is a decimal, one is a fraction, we say, okay, which one is bigger, which one is smaller? How can you tell? Then you have to use second approach. Then that means what? Change everything to decimal. How do you change the fraction to decimal? Just use your calculator, right? So this one, if you divide, that will be things like that. Then compare 0.52 and 0.5384. What do you think? First one is smaller, right? So you can tell by changing everything to decimals. Then you should be able to tell, right? So we are comparing fractions, decimals, and percents sometimes, right? Let's see some apps. Look your page 10, right? Take a look, the page 10. Just bunch of words, many words. But doing that actually is not that bad. But understanding the questions will be your issues in this class, okay? Look at the first one. In statistics, we say that two events are independent if the probability of the second occurring is equal to the probability of the second occurring given that first occurring. The probability of rolling two dice and having the sum equal to 7 is 6/36. If you know that first die land on a 4, then the probability the sum of the two dice is 7 is 1/6. Are these events independent? You will get totally confused because so many words you don't understand the meaning in math, right? First, events you don't understand. Then independent you don't understand. Then you are rolling the dice and with probabilities there. It's super confusing. Okay? But this question will not happen on your test. You just get familiar with the terminologies and get used to, the words, get you ready for next class. So if you get confused in this class, what do we need to do? What do you do? Find the question first. Okay? The question is saying, are those events independent? You have no idea, right? But it tells you what kind of things are independent. Independent means what? If the probability of second occurring is equal to the probability of the second occurring given that first occurring. Oh well. Don't worry about it just for now. Okay? It's saying if you rolled the probability of rolling 2 dice having the sum equal to 7. Remember we just say you roll the 2 dice, event is 7, sum is 7, okay? The chance is 6 out of 36. Then another one is, if you know the first die land on 4, the probability of the sum of is 7, you can have 1, 6. Remember how to make a 7? Or what else? 2, 5, or 3, 4, right? Or you can, the first one is 6, 1, first one is 5 and 2, then first one is 4, and next one is 3. You will make total 7, right? Remember, for 2 dice to roll, total have what? 36 situations. Right, from previous section, we saw some apps. Then this is a total situation. Then this is the sum for, how do we say it? Acquired, happen, okay? For the expected situation. This is total cases. Then this is expected cases. What kind of cases we expect? Total is 7 is this. But for any 2 dice, total cases will be 36. That's why the probability is 6 out of 36. Don't worry about why it's 6 out of 36 yet. Just get some idea, sort of, right, for now. Then the question is saying, are they independent? Depends. Okay? And second, what kind of things we are saying? If you know the first die lands as a 4. First die lands as a 4. Right? And the probability sum of 2 dice is what? 7. Chances is what? 1/6, it says. Okay, so it is saying if 2 fractions, we have another fraction is what? 1/6. Okay, if you know the first die land as 4, then the probability sum of 2 dice is what? 1/6. If first one is 4, then second one can be 1, 2, 3, 4, 5, 6. So the chance for this one happens is 1/6. You don't really you have a hard time to figure out why. But the question is, what? Are those situation independent? It says what? It means, okay, it is saying what kind of things are independent? If 2 fractions, okay, the same, the events will be independent. If the two fractions not the same, then they are not independent. Okay, you will learn the independent idea in your stats class. For now, we just kind of introduce the terms. This one will not be on your test. So to decide if it's independent, that means we want to find the two fractions the same or not. So one fraction they give you two is 636, one is 1/6. So are they the same? It's 36, 6 out of 36, and 1/6 are the same. If you times 6, they are the same. Yes, they are the same. That means this statement is, conclusions is that the events are independent. Okay? What a pen. Okay, that's what it is. But we just introduce you the terminologies and ideas, some idea, you have no idea what it is yet. Okay? But the second one is a little bit better for you. Okay? So let's see what are they talking about for the second problem. It says, in computing probabilities for a uniform distribution, fractions come up. Given that the number of ounces in a medium-sized drink is uniformly distributed between 15 and 26 ounces, the probability that the randomly select medium-sized drink is less than 22 ounces is 7/11. Given that the weight of a medium-sized American is uniformly distributed between 155 and 212 pounds, the probabilities that a randomly selected medium-sized American is less than 195 pounds is 40/57. Is this more likely to select a medium-sized drink that is less than 22 ounces, or to select a medium-sized American who is less than 195 pounds? You say, what the hell, right? What are they talking about? But remember, this section we are talking about is comparing, fraction, decimals, and percents. So that's a figure out, okay? Then draw the conclusion. See what kind of things we need to draw a conclusion with. So in computing probability of for a uniform distribution. So for a uniform distribution, first you don't understand distribution. What does distribution really mean? And what is uniform? Well, uniform means what? The same way, right? Same way throughout. That's what it's saying. Okay. Given that the number of ounces of medium size, okay, so for a medium size, we are talking about a drink. It's between 15 to 26 ounces. Then the probability of randomly select the medium size is less than 22 ounces. What it's saying is, okay, for a drink, it has kind of different sizes, right? So you just pick one, can be 15 ounces, 16 ounces, 17 ounces, 18, 19, 20. I just spelled it out first so you can see. 24, 25. We just use that. Okay, whole numbers. So your chance to pick up what? Less than 22 ounces means what? The one you pick can be 15, 16, 17, 18, 19, 20. Less than 22 can be those. right? So it says you can pick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me see, is that 15 to 26? Okay, to 27. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total should be 12. But how come 1, 2, 3, 4, 5, 6, 7? Okay, 8. I'm just curious why it says 7 out of 11. Okay, so it should be 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 12. But okay, that's what they say. Probably it's above 15, less than 26. It says 7 to 11. All right. Another question is what? American median size is 155 weight, a person's weight. It's 155 to 212 pounds. So 212 minus 155, that would be what? 57 pounds. Okay, so 57 in between, right? So your number can be 155, 156. So if the person is what? Less than 195 pounds, 195 pounds, from 155 to 195. So you do 195, 155. I will not test you on this one. Okay, so the chance is what? 40. So chance is 40 out of 57 numbers you can pick from. That's why. I think this one should be 26 minus 15. It's 11. Should be what? 18. But anyway, so they just choose above 150. So 26 out of 15, it's 11. And 22 out of 15, it's a 7. That's why they get a 7 out of 11. Okay? And this one is 212 minus 1. Total is 57. So between 155 to 195, it's 40. So between here, it's 40. 40 out of total 57. That's how they do. Right? Then total here is 11. So you pick from here to here. So 22 between, that's a 7 out of 11. Right? Because what happened is not exactly 15, 16, maybe 15.5, 16.5, everything in between. That's why they just choose the things in between. Okay, in between here, it's 7. Total, it's 11. So you have 7 out of 11 chances to choose those. Then here is 155 to 212. Total is 57, right? So you choose to 155 to 195. So it's in between 40. Say that's 40 out of 57. It's hard for you to comprehend right now. So just practice that. Then those will not be on your test. The whole thing is, the question is, this is the drink. This is the weight. All right. What do they want you to do? It's more likely to select the medium size drink. So how big the chance? It's a chance to do this way or chance to for the person's weight, right? So what do they want you to do is, it's more likely to select a medium size drink that is less than 22 ounces, or to select a medium size, it's less than 195 pounds. So which one has more chance? So one chance is 7/11. Another chance is 40 over 57. Which one has a bigger chance? Then you have to compare these two numbers, right? So you just change it to decimals. So this one is with 4 decimals. that would be 0.03. Just use your calculator. So 40 out of 57, that would be 0.7018. So which number is bigger? This number is bigger, right? So this one number is bigger. That means what? You have more chance to do this way than 7/11. Okay? So what are we talking about? So we are saying, okay, 40 out of 57 is easier to get there. It means what? So your conclusion would be this way. It is what? It is less likely to pick up the medium-sized drink, right? That one is for the drink, medium-sized drink, right? That is less than 22 ounces. Then for picking up the medium-sized person, that's what it's saying. Okay, so you get confused with all the numbers, but remember we are doing what? Comparison the fractions. Then one chance is 40 out of 57. Another one is 7 out of 11. Okay, which one is bigger? Which one is smaller? That's what it's saying. Confusing enough? Because those words. All right, that's what it is. Okay, let's look at the next one on your page 10, right? When we perform a hypothesis test in statistics, we have to compare a number called the p-value to another number called the level of significance, okay? Suppose that p-value is calculated as 0.0641 and the level of significance is 5%. Compare these two numbers. So many things you don't understand so far. One is a p-value. One is called level of significance. Okay? And they are used for something called hypothesis test. So you are learning the term. You have no idea what they are, but at least you start to know the names, right? Something called hypothesis test, something called p-value, something called the level of significance. You need to use those three terms, right, in your hypothesis test. And suppose p-value, you get a p-value is what? You have is 0.0641. Another one is something called level of significance, right? Which is what? 5%. But you understand the question. Question says compare these two values. Comparison means what? Which one is bigger, which one is smaller? That was the question, right? So one is percentage, one is decimals. So you will change the percentage to decimal, move to two places. That will be what? 0.5. So which one is bigger, which one is smaller? Apparently 0.0641 is bigger than your 0.05, right? How do you compare decimals? You just lined up your decimal place, right? Then you compare 0, the same, 6 is bigger than 5, so this value will be bigger. You can compare. However, how you are going to answer the question for your conclusion, right? So it's get used to write the conclusion in a whole sentence, right? So 0.0641 is for the p-value. So you will say the p-value 0.0645 is greater than the 0.05, which is what? The level of significance. That's what it is. But for comparison, you should be able to do it. Okay? So that's how we are going to use the comparison for fractions, decimals, and percent to do the stats for comparing the value, which have different meanings in the context when you do it. Okay, by then. Are we good? Okay, so this would be your section 1.3.